Alright, in example 2, they've asked us to use the second derivative test to find the relative extrema for each function. So they've given me this interval from negative 2 pi to pi, and they've asked me to locate local minimums and maxima. So let's begin by taking the first derivative. So we have f of x is 1/2 x minus sine of x. So f prime of x is going to be equal to 1/2. And the derivative of sine is cosine, so minus cosine of x. And we'll go ahead and locate critical values. We'll do that by setting the first derivative equal to 0 and solving. This gives us cosine x equals 1/2. And when does that happen? Well, take a look at your unit circle, and x is equal to negative 5 pi over 3, negative pi over 3, and positive pi over 3. Now let's go ahead and take the second derivative, and that is going to be the derivative of f prime. So f double prime of x is equal to the derivative of 1/2 is 0. Cosine is negative sine, so negative times negative is a positive, and we get a positive sine of x. All right, next I want to make a table. And so let's look at our critical values. So for x equals c, we're going to consider f of c and f double prime of c. So our critical values are negative 5 pi over 3, negative pi over 3, and pi over 3. All right, so let's fill this out. So for negative 5 pi over 3, if we plug that into our original f, we get negative 5 pi over 6 minus the square root of 3 over 2. Negative pi over 3 gives us square root of 3 over 2 minus pi over 6. And finally, pi over 3 gives us pi over 6 minus the square root of 3 over 2. Now we're going to substitute those same critical values into our second derivative, and we're just going to look at the signs. And so substituting in, again, I would put sine into your graphing calculator and just drop these values in one at a time. And I'm only interested in the sign of my output: positive, negative, and positive. All right, let's take a look at our conclusions. All right, now let's remind ourselves quickly of the relationships among f prime, and f double prime. So I'm just going to I'll write it up here. That's not enough room. All right, let's try this. F prime, f double prime, plus, minus, up, down, concave up, concave down, plus minus, up, down, concave up, concave down, plus minus, up, down, concave up, concave down. Now I want you to pay attention to f and f double prime. Notice that when f double prime is positive, the original function is concave down. So what does that mean? That means that we have a minimum. Notice that when f double prime is negative, we have the original function being concave up, and that means it has a maximum. And when it's positive, again, concave down, or concave up, and that gives us a minimum. So let me erase this, and let's write down what we know. At f of negative 5 pi over 3, it is approximately negative 3.484. That's a local minimum. We have a local maximum at f of negative pi over 3. And again, the exact value is square root of 3 over 2 minus pi over 6, but approximately 0.342. And we have a local minimum at f of pi over 3, approximately negative 0.342. I also created a Desmos file showing all of the graphs for f of x, f prime of x, and f double prime of x with vertical asymptotes at, or rather vertical lines, graphed at each one of the critical values, and so you can see what's going on here. So I'll include that in the Google Classroom.